All right, so we're going to look at notation, foundations of geometry. So first of all, we're going to make like a little analogy here. So if you look at these signs, what do they mean? So the first one's like crosswalk, second one's, kind of beware of the person on the bike, and then the third one to the right is stop, don't walk, right? All right, what about these? Tells you how the road's going to curve, right? It gives you a smaller version of what actually happens in the real world. These, a couple of different symbols for railroad tracks. We got falling rocks, deer crossing, duck crossing. Again, it's like a little miniature of what actually is going to happen in the real world. Don't turn. So how is this related to geometry? Well, there's some things in geometry that happen in the real world that are so big that we have to have like a little miniature sign for it. And that's what we're going to talk about today is notations. So a couple of definitions to start out. A point. A point is one of those undefinable terms because it has no height, no depth, and no size. It means it denotes a location and nothing else. Capital letters are used to define or to denote a point. So this would be the picture of it, and if we wanted to write about it, we would say point A. We use a capital letter. For points, a line, by definition, is a straight, unbroken set of points that goes forever in both directions, but a line has no thickness. So here's an example of what a line would look like. And if we wanted to write that as a little street sign of what really is happening, we could write it as such. Notice the 2 points are capital, and then we have a little miniature line over top. We could also call this line BA as well. If you look at the notation above, the letter and symbols look like lines. We also use one letter in a lowercase script that could denote a line. So if this is what's happening in real life, then we could also call this line H. A plane is a surface that has no length and width. That has a length and width, but no thickness. It's a flat surface that extends forever. So here's an example. And if we wanted to make like a little street sign for it or denote that, our notation would look like such, plane ACB. So we pick 3 points that are in the plane that do not lie on the same line. Or if the plane has a capital script letter, a line segment, a line that has 2 endpoints. It has a beginning and an end. So here's a picture of what that would look like. And then if we were going to denote that, a line segment, notice it has no arrows over the top. We can also reverse the order. A ray, a line that contains only one endpoint. So we start out at point A and then we go on forever and ever. And we would denote that. A little miniature street sign would look like such. We could also say ray AY. Notice that the A is the beginning point. What does co mean? Like co-worker, cooperates, collaborate. It means to work together, doesn't it? It means together. So collinear means together on the line. So if you notice, points F, Z, and P are collinear points because they lie on the same line. Coplanar means on the same plane. So points A, B, and C there are coplanar points. And then the last definition is an angle. Two rays that have a common endpoint, provided that the two rays do not lie on the same line, and that common endpoint is also known as the vertex. To name an angle, we could call this angle DEF. DEF is an angle. If you were going to take your pencil and you start at D on the picture, and as you read it, you trace it. So DEF is the angle. Notice that E is the vertex. You could also call this angle FED if we start down at the bottom and trace. Notice that the E is still the vertex. If there's only one angle happening at a given vertex, you could also call this angle E. Now, once they have multiple angles coming off of E, like this, we can no longer call this angle E because there are two angles in there that are happening. So you would have to use the three letters in that particular case to denote which angle, the top or the bottom, that you were speaking of. Example 1, a line containing point A. So pause the video, see if you can name these using the correct notation, and then come back. All right, here's some different scenarios. I try to write down several answers here. Either one of these would work. Make sure that you only have two letters. Two letters name a line. 2 points. Part B, a plane containing point C. So plane C, E, D, for example, would be one way. Notice that I have to pick 3 points not on the same line. So C, E, D. You can name that using 3 non-collinear points. You could also call this plane N. Right from right there, you can use a capital script letter to represent a plane. Example 2, draw and label a figure for the following relationship. So see if you can do that. There's multiple magnitude of answers here. There's infinite really number of answers. So if you'll pause the video, I'll give you one drawing, and then come back. So pause and then come. All right, there's an example. That little 2 there is a cursive capital U. Example 3. Pause the video, answer those questions in your notes, and then you can come back. All right, check your answer. There was a misprint on that last question, so you can just take that out. All right, some physical models in real life. So what do you think this might be? A line, a point, a ray, angle? It's a ray. How about this one? Yep, it's an angle. What about each one of those little seeds? Point. A line. You might even say line segment since we can't see the entire wire there. What about the dough? A plane.